Namaste friends. The previous video might have given you an insight on the definition of unit, its types, the systems of units, and the way of obtaining dimensional equation for a given physical quantity. As part of the units and dimensions and of course measurements topic, I am putting before you this video as second lecture to learn about errors in measurements. If you have not watched the lecture 1, kindly watch it using the link provided in the description of this video for better understanding the concepts of error. In everyday life, we come across a number of measurements. We go to market to purchase provisions, vegetables, clothes, etc. Incidentally, today, while uploading this video, we are on the last day of 2023. A section of our society celebrates the beginning of New Year 2024 tonight. Suppose that someone buys a cake of 1 kilogram mass. The vendor weighs the cake and provides you the same by taking its price. For verifying the mass of the item you have purchased, if you weigh it using some other weighing instrument, you may realize that mass of the cake is 950 gram. That is 50 gram less than what you expected. Now you will start thinking that the vendor has cheated you by giving 50 gram less. Although there is a chance of cheating you, you cannot rule out that one of the weighing instruments is associated with an error due to wrong calibration or due to some other reason. Then what is error? So error is the uncertainty involved in the measurement of a physical quantity using an instrument. And this error is classified into two types based on sources of errors. One is known as systematic errors, the other one is the random errors. Systematic errors are those errors which tend to be in one direction, whereas random errors need not occur in the decided direction. For example, systematic errors happen due to improper calibration of instruments, or imperfectness in following the procedure in handling the instrument, or the carelessness of the person who is handling the instrument. Whereas the random errors are not under the control of the person or the operator. They occur irregularly due to unpredictable fluctuations. For example, temperature fluctuations, voltage fluctuations, or vibrations of instruments, etc. For instance, if you are measuring the electric current passing through a material, that measurement may be depending on the voltage value. And if there are voltage fluctuations in the source that you are using, then the value of the current, electric current that you measure need not be error-free. So such errors are known as random errors. Further, based on how we measure, three more types of errors are defined. One is known as absolute error, the second one is relative error, and the third one is percentage error. Absolute error, this is the magnitude of the difference between the individual measured value and the true value. Now we need to understand what is the true value. This is clear about the individual measured value. The value that we measure using an instrument is the individual measured value. In order to reduce the error, we usually take the average of a number of measured values. That means the same physical quantity will be measured using an instrument for 5 or 10 times, and finally we take the average of those values which have been measured using an instrument. and that average value will be treated as the true value if we are unaware of the actual value of the physical quantity. Just for the example's sake, let us assume that a physical quantity is measured so that its value is A1 during the first measurement, and during the second measurement A2 is its value, during the third measurement A3. In this way one can measure the values and record. So n number of values have been measured as per this example. Now in order to take the average of all these individual measured values, we just take the sum of the individual values and divide it by the number of values that you have measured. If you have measured 10 number of values, divide it by 10. If you have measured 5 number of values, divide by 5. So that you will get the average value or the mean value of the individual measured values. As I mentioned earlier, this A mean can be treated as the true value when we don't know the true value or actual value of a physical quantity. And now let us realize the definition of absolute error in terms of the example. So what is it? The absolute error of the first measured value is the difference between that measured value A1 and the average value of all the measured values, that is A mean. So now look into the definition that I have given at the top of the slide again. Magnitude of the difference between the individual measured value and the true value. So true value is A mean, measured value is A1 minus A mean is the absolute error. Similarly, for the second measured value, delta A2, which is obtained on taking the difference between A2 and A mean. Similar is the case for the remaining absolute errors. And when we take the difference between A1 and A mean or A2 and A mean, there is a chance to get negative value as well as positive value. But for our estimation of errors, we need to consider only the magnitude, means only the positive values have to be considered. Relative error is the second type of error, which is defined as the ratio of mean absolute error to mean of individual measured values. That is, relative error is equal to delta A mean divided by A mean. So we take the average of all the absolute errors, that is delta A mean. We divide it by average of all individually measured physical quantities. And the third one is the percentage error. If you just multiply 100 with this ratio, you will get the percentage error, which is denoted with this delta A. So the average of the absolute errors divided by average of individual measured values multiplied by 100 is known as percentage error. Let us take an example for understanding these definitions in a better way. Assume that when a period of oscillation of a pendulum is successively measured, the values obtained were 3.45 second, 3.51 second, 3.34 second, 3.65 second and 3.42 second. So there are 5 individual measured time periods. We need to estimate the percentage error. 4 options have been given in the question: 2.3%, 2.24%, 2% or none of them. So let us verify which may be the right answer. Let us first take the average of all the individual measured values. So 3.45, 3.51, 3.34, 3.65, 3.42 are added and divided by the total number of values, that is 5. So you are getting 3.474 second, but I am considering only 3.47 second. I will tell you the reason later. And arithmetic mean of all absolute errors is taken here and absolute errors are estimated on the other side. The absolute errors, as we defined earlier, they are the differences between the individual measured value and the mean value of all the individual measured values. So you are getting minus 0.02 second for the first one. Second one, absolute error for the second measured value is 0.04 second. Similarly, the difference between the third measured value and this average value gives you minus 0.13 second. And we take the average of all these 5 values and write somewhere, which is 0.084. But I am considering only 0.08 second by ignoring this 4 in the value. And relative error, by definition, product of, that is ratio of the average of the absolute errors due to the average of the individual measured values is the relative error, which is 0.023. Again, I am considering 0.02 by ignoring 3 in the value. So, for obtaining the percentage error, relative error is multiplied with 100, so that you are getting 2%. And here the question arises in your mind that why did we take 3.474 as 3.47, 0.084 as 0.08 and 0.023 here as 0.02. This is done based on the rules which have been laid down in physics for rounding of a value. And such rules will be discussed in the next video. Anyway, if I come back to the problem which I was solving, the answer is 2%. And here you have to note that if you do not round off the values properly using the rules which have been laid down in physics, you will get the answer 2.3% and you will also get 2.24%. Both are the probabilities. So, to avoid this kind of errors in your calculation, you should know the rules which are framed in order to round off the value, which I will discuss in my next lecture, that is lecture 3. In order to follow, please subscribe this channel and continue learning physics. Thank you.